welcome to 4 Dimension Infotech. In the last video, we have seen that what are the packages, what are access specifier and their types. Now, today we are learning about the most important concept from the Java is collection. So let's start.
So collection framework, we know that it is the important point. So let's we start now. Collection interface. For that collection interface, we have to store here the package as java.util.collection. So here is given that root interface of the Java collection framework defines methods of working with the group of objects like add method, remove method, size method, contents method, clear method, and the sub interfaces like list, set, and queue. The collection interface is the root of interface in the Java collection. It provides the basic structures and methods for handling a group of objects called as the elements. So key methods of the collection interface like that. These methods are implemented in all the sub interfaces, and here are the sub interfaces are given here. So first is list interface, set interface, and third one is the key interface. So for these sub interfaces, there are the some methods like add method, remove size, contents, clears, etc. So add method is used to add the element to the collection. Removes method is used to remove the specified element. Next, size method is returns the number of element, means it will give the size of the element. Next one method is the clear method. So it will remove the all elements from the given code. So these are the methods we will use in the collection framework. So this is the hierarchy for the collection framework in Java. Iterable collections having the three interfaces like list, queue, set. So list having the classes like ArrayList, LinkedList, vectors, tag. Queue having priority. DQ is the interface and ArrayDQ. Next, set interface having the classes like HashSet and LinkHashSet. Set having the interface like sorted set and sorted set having the classes TreeSet. These all are the iterables of the collection framework interfaces and classes. In map is the interface of the collection framework. In map there is the interface like sorted map, and sorted map having the class is tree map. For the map interface, there are three classes: hash table, link hash map, and hash map. So these are the interfaces. These are class. Dotted line shows the extent, and this solid line called as the implements. So solid line means so collection implements the interfaces like list, queue, set, and extends. So that dotted line show that these are the extend. So set interface extend the classes like HashSet and link HashSet. So these all about the collection framework. Next is list interface. In list interfaces there are the two classes like ArrayList, LinkedList. There is given. So we know that in list is the ordered collection. It means elements are stored in the order they are added. It allows the duplicates value, and it will access the indexed, means you can use the indexes like list get 0, so we will get the element for that index is 0. Next, here given that classes array list and linked list. So here is given that array list is dynamic array which is fast to access, slow in insertion and deletion, okay, except at the end. But in the linked list it is a doubly linked list, fast insertion and deletion, slower the access, means it is the vice versa about the array list and linked list. This is the difference between the array list and linked list. Syntax for the array list like list string list equal to new array list. This is the syntax for the array list. If we insert the elements, we have to write like that list dot add. So here list is the reference variable. So for adding the elements, write like that list dot add. And here we have given the element. For the linked list, we have to write the syntax or code like as list string list equal to new linked list. So here is the class name we have to give. Okay, so for the array list we will write here new array list. For linked list, here we write new link. Same for adding the elements. Okay, if we want to insert some elements in the array list or linked list, we have to write like that, list dot add, and then we have to add the string. Next is the set interface. Set having class like HashSet and TreeSet. So HashSet, it means there is a no duplicates and unordered list. Sets having the no duplicates and unordered lists means that set is the interface having the classes like HashSet and TreeSet. We know that HashSet is the class. In that class, there will be the no duplicates are allowed, and it is the unordered list. Means in the hash set, we have to set the elements in unordered way. So here is the syntax for the set. Set string set equal to new hash set. So here is the set is the reference variable. That's why we write here set dot add 1. Okay, set dot add method. So in add method we have inserted here the string as a 1. Next class is TreeSet. Same, in TreeSet there is the no duplicates are allowed and sorted in the natural order. So this is the syntax for the TreeSet. Same, if we are using the hash set, at that time we have to use the class hash set here. If we are using the TreeSet, at that time we have to use the class as a TreeSet here. Okay, otherwise both the statements are the same. Means same, it means the syntax are the same, only the change is the class here. Next, map is the interface having the class as a hash map. A map is not a part of the collection interface, but it is still a part of the Java collection frame. We know that what is collection? It is a group of object, we can say that. Framework means it is the architectures of class and interface. So the collection framework what can be is the combinations of collection and framework. Means it is the architecture of this. So a map is used to store the data in the key and values pair. So here each key is unique. First first point is each key is unique. Second point is each key is linked to a value. Means each key having a particular value. Third point we have to remember that you can use the key to get the value. Here is the given syntax for the map. So here given is the syntax for the map integer string. So here integer is the data type and string also the data type, but this is in the form of the keys and value. Okay, so one will be the key here and one will be the value here. For adding or inserting the elements we have to write put method here. So we can write map dot put method. So here we have given like map dot put 1 comma, and here is the character is given is a. So if I am calling that map dot get method, so in get I have given the value is 1, so I will get the output means return it's a. Here put method add keys and value are in the pair form. Then get method returns the value for the key. Like that we can use the remove method, contain key method, contains value method, size method, or clear method. So all these methods can we can use with the map interface. Next one part is iterator. An iterator is an object in Java that helps you to go through the traverse element of a collection one by one. Just like flipping pages in a book one by one, iterator lets you read, check, or remove elements one at a time from the list set. So for that, we use the iterator. Why we use an iterator? To read all elements from a collection like list, set. Second point, we have to remember that to avoid the error when removing elements during the loop, And third one is to work with any collection type in a standard way. For that iterator, we have these some common methods like hash and next method. So for the iterator, there are these some common methods. In iterator, there are these some common methods like has next method, remove method. So has next method is used for check if there is a next element. Next method is used for to get the next element, and the remove method is used for removes the last element returned by the next method. Iterator having the some common methods like has next method for checking if there is a next element, next method for get the elements, and remove method for remove the last element written in the next method. So these are the common methods we are used in iterator. Iterator can be used when you want to remove items while looping, or when you are working with a set, that is number of index, or we can use the iterator when you want to more control over how you access the elements. So for that purpose we can use the iterator. Next one is comparable. Comparable used for the natural sorting, that is implements compared to method. Comparable means comparable is an interface in Java that is used for the sort the objects of a class in a natural order. Natural order like A to Z, 1 to 100, etc. It is used when you want to define how objects should be compared. For example, by name, by age, or marks. So these are the examples for that comparable. If you want to say, if we want to see that the real life example on the comparable, imagine you have a list of students and you want to sort them by their marks or name. So to do this, the student class must say how to compare one student with the another. At this time, this is done by using the comparable interface. Next one is the comparator. Comparator is an interface in Java used to sort the objects in custom order. For example, sort student by name, or sort product by the price descending order, sort employees by joining dates. So these are the comparator interface for the sorting. It is used when you don't want to change the class itself to define the sorting. At that time, we use the comparator. Comparator and comparable. These both are like similar. But there are some differences between the comparable and comparator. So for that, first of all, for the comparable, interface used to sort the object using the natural or default order. But in the comparator, interface used to sort the object using the custom order. Okay, so this is the first difference between comparable and comparator. Second one is comparable, having the logic written in the inside the class itself, but in the comparator it is a separate class that is outside the main method. This is the second one difference in comparable and comparator. Next, third difference is like that method used. Okay, so in comparator we use the method like compare to, in bracket here we are writing the student as that is the object. So for the method we have write like compare to method, and in comparators we write method compare to like this. Okay, so here is the object 1, object 2, so means number of methods we can call here. Next one, sorting type. Okay, so in sorting type, comparable only one way, that is natural sorting, but in the comparators you can write many ways to sort. Next difference, in comparator it can sort by the multiple fields. No. Okay, comparable, it will not allow to the multiple fields, but in the comparator it allows the different comparators, means it will create the different or multiple fields. And the last one difference is that comparable, it is used for the collections dot sort list. Okay, and comparator, this is used for the collection dot sort list and comparators. Here is the simple example for the comparable is sort by the marks inside the student class. Okay, means here is the sorting of student with the help of marks. Okay, and next one is the comparator. For that, sort by the name, city, age, etc. using the different classes, means there are the some multiple fields. Multiple fields like name, city, age. So here are the different comparators are used. So these are the main difference between the comparable and comparator.
This is all about the collection. In the next video, we will learn it practically. Until then, keep coding and keep learning.